So let's talk about why you should want to measure concentrates. What's important about them? In this picture here, we see on the left-hand side where I've said it is initial contact. So what we're saying here, this is the initial suspension as you make it, and what you see are little particles in red, and the little blue dots are essentially what I call the surface chemistry nature of the particle. Now this could be actual something absorbed on the surface. It could actually be the particle itself that has a limited or fixed solubility in the liquid in which it sits. So what happens here, we now have a situation on initial contact for those number of particles where you put it into the liquid, and at some point you get an equilibrium, a chemical equilibrium between the surface and the liquid, and that's what we see on the right hand side. So as equilibrium, we now have an equilibrium system where anything that potentially can dissolve from the surface, now sits there, and we have particles in equilibrium with the liquid in which it sits. So what we see is, in fact, in here, the equilibrium is shifted towards the surface because there's only a small amount of soluble material, because at some point, because you have high concentrations of particles, you reach the solubility limit of anything that's there, and nothing else will actually basically dissolve. However, when you in fact dilute a system, what happens is, and the equilibrium is shifted towards the surface, and so the surface probed is the little icon at the bottom, where you have the particle with an equilibrium amount of surface chemistry. When you dilute a system, it affects that particle-liquid interface. It changes that chemical equilibrium. So the initial contact in a dilute system looks the same as in the first case, except there's fewer particles. But once it comes to equilibrium, now you have a different situation, because anything that can dissolve can keep dissolving because you've got a large volume of liquid and fewer particles. So now what happens is the equilibrium begins to be shifted towards solution, and in an extreme example, you get a surface which has none of this material on. The surface is different from what it was in the concentrates. So that's the important thing to take away from this, is that dilution is not an innocuous process. It doesn't mean you cannot dilute. There are ways around this to get it diluted, but if you simply just dilute the material in a liquid, you're going to affect that particle-liquid interface, which is now going to affect the wettability of that surface and anything else you're going to do with it. So measuring samples in the dilute regime do not necessarily translate always to what you would get in the concentrates, and it is always better in any situation to measure the sample as it's made, not as it has been changed, in order for you to get a measurement with a particular type of instrument.